Hello, welcome to this presentation. Now, I want to go over the basics of capital budgeting. And what I want to do is just to give you an overview of some of the techniques or tools that are used in capital budgeting. Now, I'm going to present this in a four series video where in the first part, I'm going to look at the first method, and that is the net present value, the NPV. And then in the second part of the video, I will look at the internal rate of return, the IRR, and then modified internal rate of return in the next video. And then lastly, I look at the payback method. Now, I just want to mention this. So far, we have covered a number of concepts on time value of money. We covered time value of money, where we did look at the present value and the future value. We also covered something on valuation and rates of return. Again, in doing valuation, we were able to discount cash flows. We were able to determine the yield to maturity or the required rate of return. And then we also covered a chapter on the cost of capital, and that is the weighted average cost of capital. So all these things are going to come together, or you're going to see them again in this chapter, that is the basics of capital budgeting. So what are we trying to say in in this presentation? I'm only going to give you some of the tools that we use to make decisions when it comes to capital budgeting decisions. For example, let's assuming you want to do investment in a number of projects, and you have more than two projects or three projects to invest in. And the question is, which project are you going to invest in? Again, we don't know because we don't have the data, but the point of this chapter is to give you that overview so that you have a full understanding of some of these tools and how you can use them in making capital decisions. So let's start with the first one, which is the net present value. So let's see how this method works out. Now, with the net present value, again, by definition, you can see this formula summarizes what the net present value is. So is basically the sum of the present value of all the cash flows. Remember, both the inflows and also the outflows. So the net present value is the sum of the present value of all the cash flows. So by formula, what we try to do is, once we know what the cash flows are, we try to determine the present value of all of each cash flow, and then we sum all those cash flows together. We sum all the present values together, and that will give us the net present value. And we use that net present value to make a decision, for example, on which project you're going to invest in. And I'm going to just use a very simple example, very basic example. For example, let's assume you have two projects, Project L and Project S. And this project, you invested some money. Initially, at time zero, you had to invest in. And, you know, for a sake here, we're going to assume both project will call for same investment. So you invest $100 in project L, and also S will also require an investment of $100. But then thereafter, you end up having some inflows where, again, the cash inflows for project L is 10, 60, 80 over 3-year period, and for S is 70, 50, 20. So again, we said what we need to do is to determine the net present value. Again, there's so many methods you can use. Again, from what we just learned from previous chapter, all the way from time value of money. You can use a financial calculator, you can use financial tables, you can use the Excel. So all those methods are still available to you in trying to determine what the net present value is, because again, remember, what we're doing here is just to determine the present value of the cash flows, and then we sum them together. So I'm going to use this to be the present value for L, and this will be the present value of the cash flows for S. Now remember, by formula is very easy. We are given the formula. What you do, you take the cash flow and you discount the cash flow using a required rate of return. In our example, we're using the weighted average cost of capital, which is given to us, and we're going to say this is 10%. And therefore, you discount each cash flow to the present. So in this example, the present value of 100. Again, you divide this with 1.1, and that is 1 plus r. Our r is 0.1. That's 10%. So 1 plus r is 1.1. So you discount this at times t, and in this example, our t is 0. And any number raised to 0 is basically 1. So this is the same thing saying minus 100 divided by 1, which in this example is going to be minus 100 for L. And of course, that's also true for S. The present value of that will be 100 because they have the same amount. For the second inflow of cash, you have 10 for L and 70 for S. Again, for the case of L, you discount this. Again, divide this with a 1.10 and you raise this to 1. And this 70 is 1.1 and you raise this to 1. Again, if you do it, if you take 10 and you divide this with 1.1, and this gives you a present value of 9.0909. For 70, your present value of 70 will be 63.63.6364, and so 63. And the present value again of this again will be divided by 1.1 raised to, the only thing that is changing here is t, and our t here is now 2 because this is to be received in the second year. In this example, again, is the same thing. Our t is 2, and 1.1 raised to 2 is 1.21. So you have 60 divided by 1.21. This gives you a present value of 49.5868, and the present value of 50 will be 41.3223, and the present value of this, again, you discount this to the present, 1 divided by 1.10 raised to 3, and do the same, 1.10 raised to 3. Again, you discount the first $80. The present value of that is going to be 1.1 raised to 3 times 80. This is 60.1052. And for the other one, will be 15.0263. So again, the net present value is the sum of all the present value. So what you do, you just sum all the present value. You do the same thing, sum the present value, and what you found out to be the sum of this. For example, if you sum this together, uh, you'll find this to be, if you just sum everything together, this will take you to 100 plus minus 100 plus 9.0909 plus 49.58. This will give you a present value of 18.79. If I just round this should be 18.79. And the, the, the net present value of project S, again, we sum everything together, they should give you a present value of 19.98. Again, the NPV, the net present value for L is 1879 and the NPV for S is 1998. Again, you could use you could use Excel to do the same thing. Again, if you're just using Excel, I can show you quickly. It's a two-step process. So if you're using Excel to find the present value of these cash flows, so let me just show you how you go about in determining the present value of these cash flows. So you have two projects. You have project L and you have project S. And for S, you have cash flow minus 100, you have 70, you have 50, and then you have 20. And then for project S, you have minus 100 as initial outflow, and then you have 10, then you have 60, and then you have 80. Again, this is a time 0, 1, 2, no, sorry. This is your time is at times 0, 1, 2, 3. Again, to determine the present value, there's a two-step process. So what you do is you determine the present value of your positive. With Excel is a different way to do it. So you can just do sum everything together. So what you do is you determine the present value of the 10, 60, and 80, and then you add to the present value of minus 100, which is minus 100. For S, you do the same thing. Determine the present value of the 70, 50, 20, and add this to the present value of minus 100. So in this example, you have your NPV for just for year one, year two, and year three. So your NPV again just for year one, year two, and year three. Again, this is being invested at the cost of capital, which is 10%, and therefore your values we are looking at is 10, 60, and 80. And you sum that together, and that gives you a present value of 118.78, excluding the minus 100. So your NPV then will be you'll take the initial outflow and then you add to your the net present value of the cash flows from year one to year three, and this will give you, hold on, there's something wrong with it. It's supposed to be plus. You add the values, and this will give you a present value of 1878. And for project S, what you'll do again is the same formula. You get 119, and here again what you're going to do is just to add the two values, and if you do so again, you get this to be the present value of this to be uh, 1998, and the net present value for S to be 1878. So in other words, how do we use this information to make decisions? So if you are going to invest in these two projects, which one are you going to select? Are you going to select L or S? It depends. So if these two projects are independent, if the projects are independent. In other words, the cash flow of one does not affect the cash flow of the other. In this case, you'll choose both, and the reason why you're choosing both, they have a positive NPV. So you'll end up choosing both because, again, remember, you are able to recover your initial investment, and you have $80 million more here in this project. Again, it's the same thing. You're able to recover your initial outflow, and you have a positive increase in wealth of 19 million, and so on. So in this example, you'll choose both if they're independent. In other words, this cash flow do not affect the cash flow of the other. If these two projects are independent, you are going to choose both of them. However, if these projects are if these two projects are mutually exclusive, in other words, the cash flow of one project will affect the other. So if you choose one, then the cash flow are going to be affected. In this case, then what you're going to do, you'll end up choosing the project that has the highest NPV. The highest NPV. In this example, the highest NPV is project S. So you'll choose S if they're mutually exclusive. But if they're independent, you'll choose both of them because both of them has a positive NPV. Again, this is just how you're going to use this information to make a decisions on which project to choose. Again, you could use any other method to find the net present value. Here I showed you how you can use the formula and how you can use Excel, but remember, you can also use the financial calculator. On your financial calculator, you have a cash flow key, and therefore you'll use your cash flow key. You'll have to enter all your cash flow at times 0 minus 100, cash flow year 1 10, year 2 60, year 3 80, and then you'll enter your uh, required rate of return, and that is the discount rate for the cash flows of 10%, and then you just have to compute the NPV. And in your first example, again, you'll find this to be 1879, and you key the cash flow for the other one, and again you'll find this to be 1990. Again, it's a quick way of finding the NPV. So just keep in mind how you end up using this information to make a decision, and that is the capital budgeting decision. So I'll be looking forward for the second series, which is going to cover the internal rate of return, the IRR. So see you in the next video.